to Discovering Geometry with Mrs. Berry. This is Lesson 59. Today we'll be talking about story problems and how it's important to draw a diagram. Drawing a diagram always helps us to picture a difficult problem. Look for special relationships in your diagram, such as congruent polygons, parallel lines, or the special triangles we've just been learning about. Example 1. What is the longest stick that will fit inside a 24 by 30 by 18-inch box? So at first you might think, well, it's 30 inches, but that's not true. 30 inches is only the length of one side, and we could fit a long stick from corner to corner across the box. How are we going to find out what that measures? Well, luckily in this picture, the book has actually already drawn a triangle for us. Do you see the triangle with the red and the blue dotted line and the 18 inches? Let's draw that separately out here. This is a 90-degree angle because it is along the bottom of the box and up the side. This hypotenuse is what we want our stick measurement to be. Now, what do we already know? We know that this height is 18 inches, and we know that this is the diagonal across that bottom. So here is the bottom rectangle, and this diagonal is the same as this line down here on our triangle. So how do we know what that diagonal is? The bottom of the box is 24 by 30. It's also going to be a right triangle. I think I see how to do this now. 24 squared plus 30 squared equals the length of that diagonal squared. This is Pythagorean theorem. A squared plus b squared equals c squared. So 576 plus 900 is d squared. 1476 is d squared. So d is the square root of 1476. Because I'm not finished with the problem, I'm not going to put this into my calculator and get a decimal answer yet. I don't want to have to round and estimate too early in my problem. I'm going to transfer this square root of 1476 over here to this picture. And now I'm still looking for the hypotenuse of this triangle. I'm going to use Pythagorean theorem again. So now I have 18 squared plus the square root of 1476 squared is equal to the length of my stick squared. 18 squared is 324. When I take the square of a square root, it's just the number inside, 1476. These add up to exactly 1800. Now I'm going to take the square root of both of these. My stick is going to be, and at this point I'm going to put this into a calculator and get a decimal answer and round. So it's 42.426. I'm going to go ahead and round that to 42.4. And what am I working in? I'm working in inches. So my stick could be 42.4 inches long. About this one, find the perimeter of an equilateral triangle whose median measures 6 centimeters. What is the median of an equilateral triangle? Well, in an equilateral triangle, it's also going to be my altitude. When I draw this in here, I know this is 90 degrees, so I have a right triangle. This looks good. I have a right triangle. Right now, I only have one side length. How am I going to find the other side lengths? Hopefully you also see that this is a 30, 60, 90 triangle. If this is equilateral, then this measure is 60 degrees, which corresponds to this one right here. If I have 90 and 60, then my top one also has to be 30. All right, what's my relationship between a 30, 60, 90 triangle? This would be x. The 6 would be x squared of 3, and the hypotenuse would be 2x. So how do I figure out what x is when I only have the x squared of 3 side? I like to just set 6 equal to x squared of 3 and solve for x. To do that, I'm going to divide by the square root of 3. Now, usually, we don't leave a square root in the denominator, but we haven't really talked about rationalizing denominators yet, so I'm going to leave it for now. If this is what x is, then what is 2x? Well, it's 2 times 6, so 12 over the square root of 3. So my perimeter is just going to be 3 of these added, that is divided by the square root of 3. My perimeter will just be 3 of these added together. Or I could multiply this by 3. So when I do that, I'm just going to multiply the top. 12 times 3 is 36 over the square root of 3. And again, that was centimeters. Now, if you do know how to rationalize denominators, it means that I don't want an irrational number in my denominator. To get rid of it, I'm going to multiply the top and the bottom by the same number. And what I'm going to use is the number at the bottom because that will turn that bottom, the square root of 3 times the square root of 3 is just 3. And then at the top, I will have 36 times the square root of 3. I can then reduce this fraction just a little bit. 36 divided by 3 is going to be 12 square roots of 3. So either answer would be correct. Either you've rationalized the denominator or you have the original fraction. Problems in your homework, make sure that you're drawing a picture, labeling everything you have, and seeing what relationships you can find in that picture.